Good morning, and thank you for joining us today. My name is Kumar Ramamurthy. I'm a database specialist. I work with Google Cloud, and I'm joined by my colleague, Adarsha.
Hi, everyone. I'm Adarsha Kuturu. I'm a customer engineer with Google Cloud. So I help customers migrate to all kinds of database, OLTP-flavored databases on Google Cloud. Nice to meet you all.
Cool. We're excited to walk you through some of the most impactful performance and efficiency enhancements in the newly released Postgres 17. We are glad to announce that CloudSQL actually embraces 17 already and is GA on CloudSQL Postgres. What me and Adarsha would do is together we will explore these features in detail and demonstrate how 17 really helps you optimize your Postgres workloads from a performance and an efficiency standpoint. Like I said, Google Cloud has a plethora of database choices for you. Google Cloud has CloudSQL at its heart, which is like an entry database for people who want to run open source. And so we have three flavors of engines. One is SQL Server, the other one is Postgres, and the third one is MySQL. CloudSQL is a fully managed relational service. We also have AlloyDB, where we have taken Postgres and actually made changes to Postgres kernel to add bells and whistles like columnar engine, a read pool, and a read node-based architecture, and several other things like adaptive I/O and adaptive vacuuming, which actually makes Postgres run on steroids. And we actually are still compatible with Postgres. So AlloyDB is kind of a superior version where we bring all Google goodies to AlloyDB. It has a columnar engine, which a lot of people use, not only for OLTP, but also for HTAP workloads. Right? We also have Spanner database, which is an RTO0, RPO0, global distributed database. Sharding's done behind the scenes, and it's done at pretty large scale. A lot of our petabyte customers use Spanner. Example, Uber, right? We have our NoSQL database, which is Bigtable, and then we have Firestore and Memory Store as our database caching solutions. Outside that, what we have is a data migration service, and also data streams to move data from one platform to another. And over the last couple of years, what we've done is we've built in state-of-the-art GenAI and vector capabilities across the database portfolio. And we're making sure that things like Graph, Cipher, QL is all added to most of our databases. And Spanner actually has graph capabilities right now. So the ability to mutate between graphs and actually mutate between data is available in Spanner as of now. So that's the portfolio of databases. We have people who actually embrace, based on their workloads, they find the most suitable choice to run on Google Cloud, and then they choose the database to run on Google Cloud. Like I talked about CloudSQL, CloudSQL is our fully managed relational database service designed to provide seamless experience for running Postgres, MySQL, and SQL Server on the cloud. It's built on 5 pillars. It's built on open source. It's compatible with open source, and we keep up with open source. High availability. It powers relational workloads, and it has robust security, privacy, and compliance features. And the best part of it is you get a very good price to performance ratio on CloudSQL, no matter which engine you choose. CloudSQL takes the complexity just out of running databases, takes out all the management complexity. HA is provided out of the box. You have DR options, cross-region replication. Again, like I said, it's fully compatible with our database engines, making migration a breeze, so you can actually homogeneously kind of migrate over to CloudSQL pretty easily. One of the biggest factors, a lot of our customers, which is a big 95% of our customers, start using CloudSQL as soon as they start using Google Cloud. And you can see some of them are running most of their OLTP workloads on CloudSQL. Over the last couple of years, what we've done is we've made it a little more developer-friendly. We've added things like enhanced query insights. We have added things like Gemini for databases, so that, and also a Cloud Data Studio, so that it makes developers' life easier on these managed Postgres, MySQL, and SQL Server databases and engines. A couple of other things from a manageability standpoint is some of our large customers have a lot of databases and instances. And so we created something called Database Center, which is like a single pane of glass where you could double click into any database that you can tag by a label of environment, prod, test, or dev, or you can tag it by region, or you can actually filter or slice and dice any database and get into it and try to administer from one single pane of glass, and that's called a database center. A lot of people who have a lot of instances actually use Database Center as their one-shop operations window, and they actually use that to administer the database at ease. Near zero downtime maintenance is another big feature that we added over the last couple of years, which makes migration and maintenance pretty easy. That feature actually helps with our customers have less downtime when they actually have to do maintenance and migration activities. I'll move on to the heart of today's topic, Postgres 17 on CloudSQL. This release brings significant improvements in security, SQL JSON handling, merge command functionality, and very efficient vacuum operations. All of these and many other improvements in 17 we see are the prime things that our customers are asking of us, and they are actually using these as levers for them to actually make their jump onto 17. A lot of our customers have actually reported that these three features are probably the major features why they're able to actually move their workloads quickly to 17, and they're actually trying. Some of them are already in pre-prod and prod. What we will do in our chat today is we'll take 5 different pillars of enhanced security, developer experience, performance improvements, tooling improvements, and enhanced observability. And we'll kind of go into some features that 17 has advanced. And what Adarsha will do is she will go through those in detail, and she also has a cool demo for you guys to look at. Right? Feel free to keep it open, ask us questions at the end. We'll be available after the session also to answer any of your questions.
All right. So I guess before I get started, so how many of you use Postgres today? Everyone? Yeah. So because we are at a Postgres conference, so it's evident. So let's start. Let me go ahead and start with the enhanced security. So the enhanced security is I wanted to focus on the PG maintain role. This is a new privilege that is only offered on Postgres 17. So it gives us if you have like a third-party tool that does maintenance and it requires maintenance access, but you don't want to give them super user access, this is where that comes in, where you can just provide them vacuum, analyze, reindex, or cluster access that comes as this predefined role. And one more thing is that any kind of off-peak hours maintenance, you as a DBA don't want to be on call. You have an operation engineer on call. You can give them the access as well. And then it reduces the security risk. If you have tight audit controls, then you can segregate the maintenance users versus your application users. So those are some of the use cases where this new maintain privilege will be really helpful.
We've seen that for compliance and regulatory reasons, separation of duties for roles in banks and many other insurance agencies actually mandate that these privileges be separate. People don't own those entities, and they're able to actually do maintenance operations separately. So PG maintain is actually going to give people who are doing those maintenance activities that relief. They're not owners, and so from compliance perspective, that they're not given ownership, they're only given maintenance, and that's what PG maintain does.
So this is a really, really quick example of how you would just create a user. You have a sales history table here, and then the user tries to vacuum, but they haven't given that access, right? Because you only gave them the select access. So you can just grant them the PG maintain role, and then they are able to vacuum. So you don't actually have to give any extra elevated privileges just to run vacuum. So the second one is developer experience. So I guess merge is something that recently got introduced. So think of merge as matching. So you have like 2 data sets, right? Source data set and a target data set. And merge is something that goes and looks at the source and verifies if that is present in target or not. So a simple analogy is like, think of yourself as a postman. You went to an apartment, you have a stack of letters, and then that is your source, whereas the target is all the mailboxes. You want to just make sure you match and put the letters in the target mailbox. Let's say you don't have a match, then you'll be like, oh, this house needs a new mailbox. So how does the matching actually works? So when it actually is merging the source to target, if a match is found, then it goes and does a activity. Either if a match is found, then it's updates or deletes. If there is no match, it is insert, just like our mailbox. So what is different, right? So this is the experience on 16. On 16, there is no direct feedback. If you want to get what happens after the matching, you have to run additional queries. So that is one of the main thing on 16 where it's not supported. Let's move on to how it works in 17 today, right? So in 17, we have, apart from these two, which we already have as part of the 16 one, these are the new ones. One where when not matched, what is the action that it needs to take, right? So it just updates the unmatched target rows. And there is this new returning clause that helps the merge action, to kind of give you an audit action, like, oh, did you update? Did you delete? What is happening? You don't have to run additional queries for that. You just have to use the returning clause in the same query.
This is pretty huge for most of our customers who use quote unquote upsert kind of activity, right? When actually they have updates coming on, what they do is they use the match in 16, right? But when they do the merge match in 16, they don't get feedback for them to actually know what really happened. The returning clause is giving them the ability to see what the merge actually did. So and they're getting that within one SQL call. Previously, if they wanted to find out what the effect of the merge was, they had to do another SQL call. Yeah. Right now, the returning clause is making them get that in one SQL call. And it's a big deal for them. Many of the customers who actually have slowly changing dimensions, 1, 2, and 3, they actually benefit. And large bulk uploads, updates, they benefit from this feature pretty heavily.
So this is a simple example of how we have 3 different DML statements in one query. Before it wasn't possible to do that, to have all 3 of them in one single query. And then here you have the returning clause. So you have these 3 that are coming out as an output. And then merge action actually is one more function that kind of highlights the operation of what happened. So if you see the output on the right-hand side, the action taken is the merge action. So you know that this person or this particular user had like an update of salary or a delete of a record. So you can actually track that using merge action, and that actually benefits into your audit too. And you can also implement as part of, like, if you have any CDC kind of operations and you want to keep track of updates or deletes, that also can be used here with merge. So the next one in the developer experience is the JSON table. So this is pretty straightforward. So if you're loading any kind of JSON data into your Postgres database, before the view of the JSON data is actually, it still shows up as JSON. But with the JSON table function, you can just view it as a relational model, like you would see it as a table. So this is especially useful if you're having multiple APIs pushing JSON data into your Postgres and you want to view it together as a table. That's one. And then if you are having all the logs that are getting generated in JSON and you're pushing to Postgres, but you want to have an easier view of the code, then that's one more. So these are some ways where you could use the JSON table function in real world.
This is again useful when you have most microservices architecture and most microservices return data in JSON, and they give you multiple JSONs. And if you want to move those all into a tabular format for you to process, you actually have to make many calls. Instead of that, if you're able to look at all of that stuff in a JSON table, you're able to actually look at all of those JSONs returned in one entity, right? So that's pretty useful, right, for people. So all these changes like this merge and JSON are going to make people make changes to their existing processes and speed up their existing processes. And that's what we are seeing being reported by our customers.
So let's get to the topic. So I'm going to have a demo on vacuum. So we'll have a demo right after this one. So I just want to quickly touch on what are the vacuum enhancements we have. So under the hood, Postgres introduced a new data structure called TID store, which for vacuum operations, it really reduces the memory consumption that you would see for a vacuum. You know, most of you probably had changed maintenance work mem to get a better vacuum results, right? So that you probably can, probably tweak it a bit now that we have it inbuilt. And it also, previously it used to have like a 1 GB limit. They have removed that. So if you're running vacuum on really large tables, it really helps. So one of the main problems that we see is, if you're having a high traffic system where a small table is getting updated and deleted several times, or if you have several indexes on that particular table, the Postgres 17 actually introduced parallel index vacuuming. That's going to be part of the demo, which significantly reduces the vacuum time versus 16. And then the second one is that it also has new improvements on how you can actually monitor the vacuum. So we have a couple of new columns. So a couple of them are highlighted here. So if you see the heap blocks vacuumed, that which I have highlighted in red, and then the scanning heap. So here the example is, you just have a dead tuple percentage, you hit it, and then it initially scans the heap and then starts vacuuming, and you can actually see the progress in percentage. Initially it's 19, and then now we are at 93%. So you have more ways to monitor how your vacuum is running.
Yeah. We've seen that large tables, that transactional tables, which are fact table kinds, are the ones that benefit the most from this feature.
So this is going to be the demo setup. So I have a compute engine VM, which is just a Ubuntu machine. Around the same 4 vCPUs, 30 gig RAM. And then we have 2 PostgreSQL instances on CloudSQL Enterprise Plus. So a quick, small explanation on Enterprise Plus, what does it mean? So on CloudSQL, we have 2 editions, Enterprise and Enterprise Plus. So the Enterprise Plus has like multiple features with 99.99 SLA, and also comes up with a data cache offering, which is like a cache that you can attach to your CloudSQL instance. So for a 4 vCPUs machine, 375 GB of data cache comes out of box. So you can enable and disable if you are having a lot of read activity. Then data cache is very, very good for the read performance. So we would just run a Python script that iteratively creates a lot of dead tuples, 20%, 40%, 60%, and then we vacuum those on 16 and 17, and then we'll look at the quick graph of what that's looking like versus 16 versus 17. So let me jump into the demo real quick.
So she has the same vacuum script. She's trying to change tuples and have dead tuples, pretty similar in both these instances, 16 and 17. And she's going to let vacuum run on both of them. And she's going to show the improvements plotted in a graph to see how it improved. And this is a large table where vacuum ran on both 16 and 17.
Yeah, I quickly wanted to show how the CloudSQL console looks like. So I have both the instances listed here. Enterprise Plus also shows up. And if you see, I have one more which is on Enterprise. So that doesn't have the data cache option. And so let's go to one of the machines. So I just wanted to highlight the 4 GB, 4 vCPUs, 32 gig, and you have the option of data cache here to check out. And this is on 16.4. So let's quickly go over the Postgres 17 as well. So the same thing, it's on 17.0. So this is, I kind of zoomed up so that all of you can see. So the console is looking a bit weird. So let's go to this is the VM instance. So I'm going to quickly just log into, open the folder and then run my Python code real quick. So you can see so I'm running for 500K rows.
On
So
16.
this is on 16. So initially it will run on 16. So I'm just inserting like 500,000 rows, and you can see here real quick like how I'm testing with 20% dead tuples. I have 15% updates and 5% deletes, and I'm capturing the update, delete, and vacuum duration. So I am running this in iterations. So 20%, 30%, 40%, 50%, and 60%. And then now we do the same test on 17. So same thing, I think we are almost done here. So let me capture this. So after this, it'll save the results into vacuum results, and then we have a plotted graph. So let me bring up the plotted graph here just for the view. I mean, I have to download it, but I have a downloaded one. So for the same set of rows. So let me go over the update and delete durations first. So if you see here, this is the duration in milliseconds, and then this is the dead tuple percentage. So if you are noticing, the updates and deletes actually don't show much of a performance difference, to be honest, right? So they are almost the same on Postgres 16 versus 17. 16 is showing up as in blue, and then 17 is green. So pretty much the same performance. But let's look at the vacuum one. So if you see for the vacuum, we are going in duration. So we're going in the dead tuple percentage. So if you see for 16, we are like around 220 milliseconds and kind of getting lower. But for 17, we do like a pretty good performance when it comes to the 60%. We are like finishing up at like around 125 milliseconds in duration.
So if you have frequent updates on a large table, 17 is going to vacuum your table faster, very faster.
And the only thing that I changed but between 16 and 17 is I added parallel option for index vacuuming, which is not there on 16. So that's why all the indexes get vacuumed parallelly, which is giving us this kind of performance where even with large number of indexes, you would have the vacuum being very performant.
Yeah. And typically what we see in up until 16 is we will see that at some point when the table actually needs vacuum and they can't do it because it's during their business critical day, the explain plans for the query will actually go a little awry, right? They'll go a little out of order. But this will actually enable you to run a quick vacuum if needed, and then you'll be able to get back the same explain plan. So that's the advantage. You may have the opportunity to run vacuum multiple times during the day because the elapsed time is pretty small.
And you also have the option to do index-only vacuum. So if you have to just vacuum index, you can do that too. So let me go back to my presentation. And then, so a couple of performance improvements on IO side. There is a new read buffer API enhancements under the hood, which gives you better IO performance. It significantly reduces the threshold for that. And then what it means is you get faster sequential scans, and then you have reduced IO wait time. So if you're capturing the IO wait time using your graphs, then I would recommend you to monitor how it is performing on Postgres 17. And in a real world, what exactly it means is if you're having any nightly ETL jobs, you would see the performance going up for those because you're doing batch inserts or batch updates, basically batch DML. And the increased IO combined limit, that also gives you a better performance for the ETL jobs. And basically, I guess to make a point here, it's any kind of bulk processing operations will perform better because of the IO optimization. So a couple of more in performance improvements. If you're having, a null handling, before we didn't have like a specific optimized, null handling in Postgres. So they have added that. So it really removes the redundant checks that you have to do as part of your daily queries, and then it also gives you a more query efficiency. So a quick example here shows like if you're having a table where the integer is like ID is not null and name is not null, if you're running a query, then when I'm querying the ID which as a null, right? what it does is it just runs the filter, and it just gives you that, oh, it filtered and said that ID is not null. But whereas for when name, which is not null, and you are running a perfect query, then it's not using the filter at all. So if you're using a wrong query, it will still give you the better results using the filter. That's what it means. So a couple of tooling improvements if you're doing export and import on a nightly basis for your reporting or something of that purpose where you're using copy commands. So previously, if you're using any copy command and you have a different format, like for example, in a CSV file, instead of a number, we have an alphabet ABC there. So the copy command used to fail before, but now you have the option to just skip it, like where you say on error ignore, so it will just skip those errors and kind of prints them out. It was not there before. So it really is useful if you're doing any kind of copy commands or as part of migration projects. So a couple of more improvements on dump and restore. So we have more fine-grained object control. So if you had to filter a database or add or remove a database from the PG dump, before it had to be in the command itself. But now you can actually create a filter file and then pass it as a filter. So I want only these databases. You can put it in the filter file and then give it that. And then also when you're restoring, let's say you're restoring a large database, then and your machine is a smaller one. So you can actually control the transaction size. Before, we didn't have that option. We would just beef up the machine for that initial load, and then once we get into the change data capture, you kind of reduce the size. But with transaction size, you can actually control that. So that way, the initial dump, you don't have to worry about resources based on the transaction size. So this gives you more ability on how you want to do that initial dump.
Yeah, when you used to do restores before, you had no control over the resource group and something called transaction bloat in Postgres. This gives you a lever to control the transaction bloat when you actually do the restores.
So especially if you have to work with your infrastructure management team to upgrade the instance and then downgrade the instance, those kind of issues, you don't have to bother with the transaction size. So we are almost at the end. So we have the observability piece, which is the last topic. So a couple of observability additions that were made in PG17 was that PG wait events. So you can process the wait events and you can kind of club them with the PG stat activity and can get the wait event details. And any kind of bottlenecks or troubleshooting that you want to do, you could use the new PG wait events. We have added a couple more there. And then the stat checkpointer, that's a new one too. So to better understand the checkpointing process, the Postgres 17 actually is now giving you the PG stat checkpointer view. This gives you a valuable information on checkpoint frequency, the volume of data. So it gives some, and you can also monitor the completion times. The key metrics that you want to look out for is the checkpoint frequency and checkpoint IO impact. So those are actually the outputs that you want to look at was the num timed. That gives you what is the frequency. And then the write time and the sync time gives you the IO impact, like what is the time taken? Are you using significant IO resources for checkpointing?
So for example, if you were running daily operations and suddenly one day you see that your system is actually slower, right? And there were some writes happening. Then what you could actually do is you could go and check the num requested on this view to say, okay, the number of times checkpoint was asked to be done has increased significantly today over the past. So that means that we are getting heavy writes, right? And so you know that something has been different in your traffic pattern that has actually resulted in the checkpoint being called often. So this level of granularity gives you, and you can set up alerts on this one to say, right, something has happened or something abnormal has happened or something out of the normal has happened. And you could actually right mechanisms and alerting mechanisms to trigger an email or a notification to you saying that, something has happened, just look at it so it makes you a little more proactive instead of being reactive. So this view actually is going to help a lot of people who actually see spikes that they don't expect.
Go ahead.
Are you doing questions now or at the end?
Yeah, we'll take questions right after this. We are almost to the end. Yeah. So one of the real world use case I have seen is that we had one customer who had like a pub sub kind messaging that is going to like push a lot of messages into the Postgres database, and then they had sudden workload that came in, and then we had like so much checkpointing happening. You remember that one, right? So this kind of metrics would have helped troubleshoot the issue way earlier. So I think that is really useful when you are like trying to see what is happening with your database. So we're at the end. So you had a question. You want to go ahead?
I guess that just shows you a cumulative figure. Is that the PG stat checkpoint?
Correct, it is a cumulative.
Okay. Because I was thinking about like you all have recommendations on using that information to tune the checkpoint timeout.
Yeah, ultimately that is, so if you, for example, through a normal day, let's assume that Monday to Friday is your business day and you see X number of checkpoints throughout the day, and then suddenly you see linearly higher or exponentially higher checkpoints, certainly you actually can tune other checkpoint parameters that at least give you ammunition to say that, okay, on particular days, and maybe you can observe for those patterns and see if that has to be changed. One of the features that some of our Postgres AlloyDB is a database I was talking about, right? We do adaptive vacuuming, and we do adaptive I/O too. The way we actually do this is by checking the dictionary tables for all of these things and kind of see if the operations can actually set these checks and these parameters on the fly. So now it gives you control. If you're running pure Postgres, you could actually do that, right? You have these views. You never had deeper insights into these parameters before. It just gives you a mechanism for you to control it much more better.
Go ahead.
Very simple question. The checkpoint number that we saw, basically as you mentioned, it's a cumulative number.
Correct.
So when you're running the query, it's the summation at that point in time.
Correct.
So basically, as a user, I have to develop something, maybe a shell script or something like that, that can run the query, plot that number somewhere, and I can see the trend. It's
Correct.
going up or going down.
Correct.
And based on that, I can take the decision.
Yep.
I mean, if there is any managed, like a way of getting those numbers
So I don't think we incorporated it yet into the, so we do have system insights and query insights on CloudSQL. So the system insights are more on the resource side, whereas query insights are more on the database metric side. So that I don't think we have incorporated yet, but I think we'll have that as, because Postgres, when Postgres 17 GA, probably GA'd like 1.5 weeks ago. So it's pretty new still on CloudSQL, so we're still incorporating new metrics.
Go back to the console where you showed the list of the databases, right? So she looked at 16 and 17 on a single, the database center,
Oh,
right?
you want to look at that?
Yeah,
one?
database
Okay.
center. That is a database center. So I talked about database center. In Google Cloud databases, what we're doing is we're creating a single pane of window called database center that lets you look at databases and slice and dice your database instances by anything. Once you double click on it, it's going to help you troubleshoot, do analysis on the database, and do all that stuff. A third feature in that database center is something called recommenders, right? Today we have, I would say, somewhat basic and medium recommenders like index recommendation and those kinds of things. What you're asking is going to be a recommender. If there is a recommender that says that, you know what, your checkpointing has gone way off, and if that is a recommender, and that is easy for us to implement because we have that framework. So we will keep adding more recommenders there. That's the... Yes, it is backed by Gemini too. So to the right of the database center,
I already have it on.
to the right of database center, what we would have is we would have like a Gemini assist console. So where you could actually ask it natural language question queries, and it could actually tell you this. It could actually even give you a script to remediate if you wanted. If I take the, today we have some recommenders. If you look at the index one, right? It could actually tell you that when you actually go into a database, it could actually tell you proactively that please create an index for this one. Then you don't want to create it right away. You want to see why it is asking you to do that. So you go double click and see, it says that at this point, I saw that your query would have benefited because of this explain plan by creating this index. And so you take that script, you run it on the studio, and then you get done with that, right? So we are trying to add more and more recommenders. I think the mechanism that we're trying to see is, should we add more recommenders, or should we actually even get recommenders from many other scripts that people have been managing Postgres for like years, right?
Yeah.
So there is like how to go about adding these recommenders, and that's something that we're working on pretty well right now.
This database center is kind of a game changer since it's backed by Gemini. I saw a presentation yesterday.
Yeah,
Of course, like the recommendations that's coming. I mean, let's say if your vacuum is not progressing well, so that's
Correct.
something Gemini is recommending.
correct,
And maybe there are certain automation behind it, which is logging inside the
correct,
and getting the information.
Correct.
Or all of the database.
correct.
So,
Correct.
yeah.
And we're going to do it across several pillars, right? So instead of doing it as a recommender, because the recommender is nothing but a script that people like us who are DBAs who have used it, right? We are actually putting that for and getting the recommendation. Instead of that, if we can go by pillars, so what are your patch level recommendations, or what are your instance level recommendations, what are your SQL level recommendations, what are your vacuum or what are your IO recommendations? You know, if you go through all of, or even what are your security recommendations, critical. So we're trying to pull those into different pillars so that the recommenders can be based on certain pillar.
So if you see here, right, we have the availability, data protection, security, industry compliance, performance, cost. So all of them
It does
are
quite a
coming.
few right now. It does quite a few.
And Adarsh, one more thing, like, I think there were some graphs. These are the only infrastructure metrics we can see on the graph. I think I saw some security
Oh,
metrics on a previous page.
oh, this one. Oh, let me see.
Or we can also see the region level graphs as well.
Oh, we can. So just trying to get that one. All right. So we have some recommenders here. Oops, sorry. So I mean, these are like single node clusters. I don't have any like failover, or because this is just a demo environment. So, but for production, if you don't have any password policies set up or something like that, it does give you the recommendations here. And then this was the metrics I was talking about. The system insights gives you like, you know, several query latency, CPU, several metrics, and then, so these are like something which you would want to see. The disk IO, read and write operations. Whereas with query insights, you would see the wait events, database load, all those details that are coming up. So my environment is kind of limited because it's a demo one. But if you see here, right, so I did several updates and vacuum. So you could see here, and then if I want to just check for this one. So this is not a select query, so I can't do actually an explain plan. But ideally, if it's a select query, you would have a visual explain plan showing up.
So what I have found very intuitive is if you're running an insert into select from, and it's running slow, and you had zeroed down into the explain plan of that one, and you found that, you know, that is slow. What it would also do very intuitively is give you complete query visibility at that point in time, what else was running concurrently. And what it will do is it will say that you were running the other thing concurrently, and it will say, but you can create an index for this one, it will speed it up. The other one, whether you run it or do not run it, it will actually show you improvements on this one. And so it will say there is a recommendation for the other one, but you can do that later. That's not going to alleviate your problem. This is going to alleviate your problem first, and so it will actually ask you to create that index. Correct. It gives complete query visibility so that at a point when you're actually having a problem, you know that the problem is caused by that, and it is not caused by anything else that is happening around. And that is very useful, and that's what we do when we troubleshoot, right? We are troubleshooting onto one because we see the symptom there. But there are several other things that might be happening in the background that might have caused that. So it helps eliminate those.
Since we are talking about Gemini-infused metrics, so the CloudSQL Studio, which is the GUI-based login, so it also has the Gemini enabled. So I can quickly log in, but so the thing here is that if you are having any new queries, like let's say you suddenly got handed a database and you have a set of queries, and you want to understand those, you can actually put them in Gemini and say, explain this query to me.
It'll make sense of
It will make sense of what you are having. So it is infused into the studio. It's the other way around as well, like where you have you can write in natural language and then it'll just pop out the query. So that is infused into the studio as well. So any other questions? So since we have some 10 more minutes.
10 more.
So if you are going by the Past Summit exhibit hall, we'll be in the Google Cloud the actual booth. So if you have any questions later on for CloudSQL, feel free to drop by.
We also
Thank
have
you.
some cool swag. You can always come and
If
get
you
that
haven't
from
picked
us.
it up yet,
Yeah,
so,
please come. We'll be more than happy to give it to you.
yeah. Thanks for dropping by, everyone.
Appreciate it.
Yeah.